today we want to talk to you a little bit about sort of our view, the Bidgely view around personalization. So let's talk about the data science driving personalization today. As you know, our goal at Bidgely is to be the makers of the world's most accurate and most actionable consumer energy profiles. So who a consumer is and what can we say about a consumer based on their energy usage augmented with other information. And this is essentially what's guiding us, right? What's guiding us is a notion that we're building a profile out based on unique information that utilities have access to, which is what makes it interesting, which is actual meter usage data, and the more frequent the better, as we've discussed, but augmented then with a bunch of other information, publicly sourced information, perhaps information from the communities that the utilities themselves begin to host as a way of encouraging dialogue and conversation, and from other public sources. And from interaction, the way Netflix, for example, learns, or even Target learns in terms of who reacts to what offer and how. So let's basically say, if this is essentially what we're trying to do, let's come up with a person. Let's call him Bob. And what we're going to do over the next 25, 30 minutes is tell you about how smart meter data can be used to really learn a lot about Bob, right? So we're going to make Bob a living, breathing human who's interesting. And we're going to find out what makes Bob tick based on the meter data. We're basically going to find out who Bob is from a consumption perspective, what kinds of appliances Bob uses, and what that might mean for what Bob should be doing. We're going to understand Bob's lifestyle based on his energy usage. And we're going to look at his propensity to buy various things. I'm not sure we'll be able to say if he likes a gray and white bag with his blue shirt or not. But let's talk about Bob's propensity to buy different kinds of energy products and services and how that might be relevant to a utility looking to offer a marketplace, right? So that's essentially what we're looking to do. I'm not qualified to tell you how we actually do it. So I'm going to ask my colleague Basant Pandey, who's our lead data scientist at Bidgely, to step up here and demystify how we turn Bob from an icon into a living, breathing, interesting person.
Let's start the fun. So before jumping into building the profile, what I'll do is give you a primer on how to visualize a smart meter data. So let's see. So we all know like smart meter data is a numerical data, which is a time series data, consists of two columns, like timestamp and value. But it's black and white. We don't get to infer a lot of information out of it, so what to do about it? So we all tend to do some visualization in our life to solve our problem. So what we'll do is, first we try to visualize this data in a different form called heat maps. So what is heat maps? So there are three things we need to understand to know about heat maps. The first one is the x-axis, which is time of the day. So from one midnight to another midnight, it's like 1 a.m., 2 a.m., 3 p.m. kind of thing. On the y-axis, it's the days. So within a year, you have months and days. So they are overlapped with each other on top of each other. So from bottom, you can see it's like 27th September. And then on top, it's 1st August. So this is something like 1 year of data stacked on top of each other. And then you got to see a lot of pixels with different colors. So what does this color symbolizes? This is exactly the consumption data, which is like how much power consumption is happening at your house at a particular date, at a particular time. So darker the color, that means you are consuming less energy. And brighter the color, that means you are consuming more energy. So now this is, you can say this is just a face representation of a household consumption. Like we have facial features, this image also have a lot of features, and it's unique for each and every house. So what are the things you see in this image? So there are a lot of inferences to be drawn out of it. Some of them are visible, but many of them are invisible. And it's very difficult for me to show you the invisible things, but let's go through some of the visible ones. So you see one patch there, it's a bright patch, but it is very consistent. What does it mean? It means like something is running daily at the same time, starting at the same time and ending at the same time. So it's a timer-based devices. And the typical timer-based device, as we know, whosoever is having pool at their house, it's a pool pump. So this is typically how a pool pump looks like. And it's very visible to our eyes. But the thing which is difficult here is it is overlapping with a lot of information which is running in the background of the house. Now you see some seasonal behavior happening in the heat map. So it's like in the summer season, again, the consumption is going up. So it is typically a HVAC behavior. So whenever temperature is high or low, some consumption spike happen, and this is because some HVAC is running at a house. Now, if you look deeper, there are some dark patches also in the image. What does it mean? It means there is low consumption for some consistent days, like say 1 week or 2 weeks. And what does it mean? That means there's no one at the house and it's a vacation period, so they're enjoying their vacation. And the last and the least, what we can infer is the lifestyle of the person. So if you see a lot of activity happening in the daytime, that means you'll see a consumption in the daytime. That means it's not like a life of office goer. There are kids or family living in the house. So you can see what we can infer from this data is in different dimensions. We get to know about appliances, we get to know about lifestyle, we get to know about vacations. But this is all good when you do it visually, right? But the goal of AI or machine learning is to do it automatically. So Bidgely is going to do this automatically with a set of code which is known as disaggregation. So I'll not take much time to make you understand what is disaggregation, but I'll just take you one example like how we do disaggregation. So now you are aware like how does heat map look like? So the left side you see there is a heat map, but for Bob we know where he lives. So what we can do is pull his temperature data as well and plot as a heat map. Now if we see here the temperature is high and here consumption is also high. So it shows a correlation between temperature and consumption. And similarly here you see it's a low temperature like winter season. Similarly you see higher consumption happening in the Bob's house. So this shows like there is a typical very high correlation between temperature and consumption, and this thing happens because HVAC is being actively used by Bob. So at Bidgely, what we try to do is learn a correlation between temperature and consumption data. So temperature is represented as a CDD or SDD, which is like cooling degree day and heating degree day. And also you get to know how the consumption behaves when CDD and SDD changes. So we fit a regression model, we learn the coefficients, and once you have coefficients, you can calculate how much heating or cooling is happening at Bob's house in a particular month. So this last image is just what everybody get to see, like itemization. So the black color bar is the total consumption of Bob's house, and you can see we are able to separate the heating and cooling in each month, and this is how disaggregation is done. This is just one example where I am showing it by HVAC, but trust me, for each and every appliance we can do it, and we are very accurate in it. So once we have this disaggregation for each and every appliance, what we can do? We are good to fill his consumption profile. What is consumption profile? For every month, you need to know like what is the power consumption happening at Bob's house, but that is not sufficient. You also need to know which are the appliances which are actively used in those months and how much they are consuming. So with disaggregation, all these information is filled up for the 1 year of data of Bob, and the consumption profile is ready to use for Bob. But this is the least you could have done with the heat map, which has a lot of information. As I said, some are visible, but many of the informations are invisible. So let's move towards seeing some of the invisible information which can be derived from the data, and using that we'll get to know about the appliances which is being used by Bob at his house. So again, what I'll do is carry forward the same example with some advanced insight. So till now we have seen just the itemization, but now we'll see some other attributes which can be calculated for HVAC appliance which is being used by Bob. So again, same thing, you have raw heat map data, temperature data, and this is what we get out of disaggregation in detail. So let me explain what are the things here. So HVAC consists of typically two kinds of usage pattern. One is like always on, and another is on demand. So what is always on HVAC? So if you are living in, say, a cold country like Canada, you need to run your heating all the time in winter season. So there will be some component of heating which will be running all the time. So you see 24/7, there is some brighter component or pixels in the image. But if your summer is not very high, it's like always kicks on from 12 p.m. to 6 p.m., then you will be using your HVAC on demand for cooling purposes. And this is like you see the on-demand HVAC usage, which is cooling. So once you have this information, what are the things you see in this image? So on the x-axis, you have time of use, right? So you know what is the time of the day at which HVAC is used. And also on the y-axis, you know the different days of a year. So basically, you are able to pinpoint what is the date and time at which HVAC is running in Bob's house. And once you know this, there's a lot of potential to get attributes or the things which are related to appliance. So in detail, if I go, so these are the informations which you can derive from the disaggregation output we just saw. So the one thing which we can know is power rating of the device, because in the heat map, as I said, the pixel color represent the power consumption happening at the house. So from that color, you can extract the power rating of the device. So here for Bob, it's like 1.5 kilowatt. Then we also know the time of use of devices. So since for every day, every time you know if the appliance is running or not, so you get to know the time of use of the appliance. Then you also, so while deriving the information, we also get to know the set point of the home. So it's like comfort level of a user, like at what temperature he wants to use his AC, at what temperature, when temperature goes below that point, he wants to use his heating. So you also get to know like his set point for summer is 72 Fahrenheit, for winter it's 61 Fahrenheit. Then we know the demand type, is it HVAC, mostly HVAC or on demand. We get to know the number of units of HVAC which is present in Bob's house, here it's 1. We also get to know the type of appliance he has. So here it's like mini split air-to-air heat pump. The last one, the information which we can derive out of this information is the thermostat. So we put this data to our machine learning, or you can say classification model, and it can say if a thermostat is present in that house or not. And if yes, then it can also categorize with some confidence what kind of thermostat it is. Is it a smart thermostat or non-smart thermostat? So now if you know this much information about appliance in Bob's house, what are the things you can do? The first thing which you can do is you can find if you are running a DR program, is this person suitable for that DR program? You get to know the time of use of the appliance. You can compare what is the peak hour. And if I ask this person to pre-cool his house, is it going to shift the load or not? So you can get pinpointed persons. It's not like you just see the total consumption. If it is a high consumption home, you target the home. It's not necessarily high consumption is happening because he is running HVAC at that particular time. It can happen because of n number of reasons, because of different appliances as well. But if you get to know all this information, you can target in a better way. So this is called personalization, right? So this is just one example we saw. Let's move to another appliance, pool pump. Same thing, we have heat map on the left side, and the right side is the output of disaggregation. In the left side, you can see the timer device is always present, but the thing is it is overlapping with a lot of information. Now in the right side, when we extract the information, we only get to see the pool pump. What are the things we get to know? Again, the power rating of this pool pump is 2.2 kilowatt. You can match this heat map, and it's a 50-minute sampling rate, so you can multiply it by 4, you'll get to know the power rating of the appliance. Now, you also get to know the time of use, so like at what time pool pump is running, so it's dual run, sometime in the night and sometime in daytime. We also get to know the type of pool pump, so there are multiple kind of pool pumps, like single speed, variable speed, and here we see it's a single speed pool pump because it doesn't change its power rating. It's running at a consistent power. We also get to know the number of units. We also get to know the behavior of Bob. Is it like he's changing his schedules very frequently or not frequent? So within a year, he changed his schedule around 4 times, so we can categorize saying, okay, he's changing his schedules frequently. And also we know how many runs a day it is being used. So now again, if you have this information, what are the things you can do? Because we have to talk about the actions. So the first thing which comes in mind is it's a single speed pool pump, right? And in the market, we have efficient pool pumps like variable speed pool pumps, which consume much less power than what it is consuming and does the same work. So he can be targeted for selling variable speed pool pump. At the same time, if you see the effect, one side you are selling your product, other side you are going to get your energy efficiency. Because the power consumption of Bob House will come down because he is now moved to a more efficient appliance. So second one is you can again target this user for shifting his load, because pool pump is an appliance which is not necessarily to be run at this time. It can be run any time a day. So if this is a peak time, like 1 p.m. to 6 p.m., you just message that person saying, can you shift your load from 10 a.m. to 2 p.m. because this will regularize the demand for the utility at the same time. It doesn't make any impact to the customer, so he'll be very happy about it. The third thing which can be done is more important, it's the personalization part again. If I know this user is changing his schedules very frequently and he is in the time of use rate plan, and if by mistake he changed his schedule to a time where his bill charges are high, we can send an alert saying, hey, what are you doing? Your bill is going to increase because you moved your pool pump to a time where bill charges are high. And then customer will feel like, wow, what is this? I mean, they are helping me out in cutting down my bill, and also he'll feel like super engaged. So these are some examples. I mean, you can come up with many examples if you have this information, what can be done, but I just showed you 3 examples, and you might be finding it very interesting, like, yeah, this is going to help customer. The next one is water heater. So again, same thing, you have heat map, you have the disaggregation, and now you can see what are the things we can derive from water heater. So you see there are 2 kinds of information present in the right heat map. One is like brighter pixels, and some images, in this image, some pixels are darker. So this information signifies 2 kinds of uses. One is active consumption, and the second one is passive consumption. So what is this? So I'll just take a minute to explain what is this. So this device is basically a thermostat-driven storage water heater. So what happens is so it's heated, it has a water heated in a tank stored, and it's going to maintain a temperature. So whenever you are going to use your water heater, you'll pour some water, and cold water will get filled in the tank, temperature will go down, and it will start heating the water. This is called active usage because you are using the water. On the contrary, there is another scenario when again it will kick in. When you lose temperature or heat due to leakage in the tank of the water heater, again the temperature will go below the thermostat set point, and it will kick in and start heating the water. So the passive usage is happening because of the insulation issue. So the features which we can extract out of this is like power rating, time of use, type of the appliance, and as I said, you also get to know what is the total water heater consumption going into passive type or active type. Here you can see it's 40% due to active usage and 60% due to passive usage. And also you know the band in which the water heater is being used, so it's a dual band. So Bob either uses it in the morning time or in the evening time. So what are the things you can derive? So first thing is seeing the passive usage percentage. It's definitely clear that he has an insulation issue because most of the energy is wasted just to maintain the temperature while he's not using it. So it's a leakage problem. So what are the things we can do? We can suggest Bob to have a repair to his water heater. But he says, okay, I don't want. There is another option also. Since he is dual band user, that means it's a, you can say activity-based usage happening at 2 times. So he is a potential customer for selling instantaneous water heater, which is much more efficient, and it just instantaneously heats his water. So in the morning, he wakes up, opens it, and he gets the water, and again in the evening, he gets the water. So we can do 2 things, either send a repairman or tell him that there is some insulation issue going on, or we can sell him the instantaneous water heater, which is like a marketplace for us. And similarly, I'll quickly go through the next one, which is EV. So Bob looks like he has an EV, and through disaggregation, we get to know the output of EV disaggregation. It shows like he is charging very frequently in a month. He's an active user of EV. We get to know the power consumption of charger, and hence we know the type of charger, which is your L2. Since we know the amount of charging happening, we can correlate with the distance commute, and we get to arrive like average commute distance for Bob is 53 miles a day. We also know the charging location, like he used to charge, he is very fond of charging his EV at home, not at office. We also know the schedule of EV charging. So what can do? Again, we can suggest Bob like what is the EV assisted rate plans, because it may happen like he is not on the plan where EV charging can be compensated with some offer given by utilities. Similarly, we know he's a rich person, so we can upsell solar and battery to him. Okay, so we talked about a lot of different appliances of Bob. So what we do with this, we create his appliance profile. So as you can see, all the information regarding heating, cooling, pool pump, EV, and water heater, we get to fill it. And as I have given you enough information, like what are the use cases can be created out of it. So it looks like, we are in the right direction. As we fill the information, we are able to exploit some of the use cases out of it. So now we talked a lot about consumption and appliances. Let's move to the next dimension. But before that, what I'll do is I'll show you another visualization. So we are familiar with heat maps. Now let's see some other visualization of the consumption data. So in a day, say you consume X amount of energy, you want to know at what time band I am consuming the most. So what you do is just add the total sum of each hour consumption. So you have total day consumption, and you divide your each hour data by that information, and we get what percentage of that total consumption is being used at this particular hour. So this is called load pattern. So you can see, like, if he consumes some amount of energy, this 70% of this is, at this point he's consuming the most, and similarly in the daytime he's not consuming, and evening time he's consuming this much. But it is relatively less than what he's consuming in the morning. So it typically shows what kind of lifestyle Bob has. So he's like, if it is a Bob profile, just giving you an example. So that means he's super active in the morning. Daytime, either he takes a nap or go out of the house. Then again, evening he comes back, cooks, do some entertainment, and then go to sleep. Let's see this one. This is the second most prevalent lifestyle. In the morning, some activity is happening, then again, flat, and evening, super active. This is a typical office goer, like I live in this lifestyle. I wake up, do some, brushing and all this stuff, and go back to my office, come back in the evening, watch movies, do some work, and sleep. So the most of the consumption is happening in the evening time. Similarly, you see there are 6 different types of lifestyle I've shown here, but I'll not go through it because, it will take a lot of time, but this is what lifestyle or load pattern is. So what we do with Bob is, we take his 1 year of data. For each day, we put it in a bucket like which lifestyle it was. And we also separate it based on the weekday or weekend. So this is the load distribution of Bob lifestyle. And as you can see, the most prominent one is the office goer, as I showed it last slide. So from this, I get to know, like, this Bob is office goer. So this one information I just concluded from the information, like the distribution of the load patterns. The second one, I see, if I plot the most prominent weekend behavior, I see a lot of consumption happening in the daytime. So it means like he's a weekend warrior. So in weekdays, he was silent during the daytime, but on weekend, he's very active in the daytime. So he might be doing all the laundry and all the stuff on the weekend. So he's a weekend warrior kind of person. So we say, okay, weekends are active. Now, since I know this pattern, I can also derive the information like what time he wakes up with some confidence interval. So I say like 5 a.m. plus minus some hours. Similarly, I can say at what time he sleeps in the night, because at that time the load pattern will go down. Also, I know the office timings, because I know during what time of the day that consumption was flat. And also, if I see the distribution, I will essentially know how often he takes the vacation. So again, same thing, like what can be done? If I see he's not taking very often, like he's not going on vacation, but he goes to vacation, and the last time he took vacation is 6 months back, I can sell a vacation package to him saying, okay, go to a vacation. Also, I know what is the timing he's super engaged. So if I have to do my EE efficiency program and I have to send an email, I'll not blindly send the email at any time, because it may be like what he'll do, he's in office, right? So I can calculate or derive a likelihood of opening an email from his lifestyle. So at what time I should be sending the emails that he's going to open and take the recommendation which we are sending. And with this, you can increase your click-through rate, you can make your engagement more better, and it will improve your CSAT score. Okay, let's go deeper into Bob lifestyle. So this is the heat map. And you see, this is December time, some activity started suddenly happening, and it's not seasonal. Because if it's a seasonal, it could have happened for January months also, but it's located into November time and December time. So what is it? It says, Bob likes to celebrate. So it's Thanksgiving and Christmas time, so he is using a lot of Christmas light, he is cooking, or whatever. So this information also we infer from it, like he likes to celebrate, he celebrates at home, and then he is using Christmas light. So what we can do out of it, same thing. If I get to know like how much consumption is happening due to Christmas light, I can sell him the efficient LED Christmas light, right? So with this, we are good to fill his lifestyle profile. Now, I'll just explain one more, because I think, I'm going much deeper into it. So let's see how the propensity profile can be filled for Mr. Bob. And then all the other things, I'll just say, like, similar way, the other profiles can be created. So deriving propensity. So what is propensity? Propensity is the probability to buy certain things. So I'll take you through example. So this is a person, and just in previous exercise, we have seen a lot of information derived. So his lifestyle is like this. So it's like office goer. Through some third-party data or whatever way we know he is a high-income group. Also, since we are doing EV disaggregation, and we have the location of the user, so we know in neighborhood what is the prevalence of EV appliance. So for this user, a lot of EVs in his neighborhood. Using this information, giving to a probabilistic graphical model, I mean, I'll not go in technicalities, but this is the word which is typically used, PGMs, and some other information which is there present in the raw smart meter data. We push it, and we get to know like what is the propensity of buying EV. It's not very simple, I'm telling you, but I just took this example so that you can correlate how this modeling is happening. So you know if EVs are around you, you always feel like, okay, yeah, I should buy it. But there are other attributes also which are there, so that's why the probability is not 1, it's just 0.75. Let's take second example. Similarly, I know he takes vacation, he's mid-high income group, he's nature lover. So what to do? I mean, again, pass it to engine and get the vacation propensity 0.85. Let's go to Bob now, again. So we have his lifestyle curve, load curve, we have the distribution, and we have a new term called insolation. So what is insolation? Insolation is the amount of solar energy which can be generated at a particular location with respect to time. So it shows like in Bob's locality, solar power can be used because sunlight is very good. And also I know the rate plan of Bob, so it's like peaking at 5 p.m. to 9:30 p.m. So if I have this information, how I can calculate propensity for certain appliances? So again, I pass this input to our engine with some other attributes, and I get to know the propensity for solar panel is just 0.2. Can anyone guess why? Because we just see, right, it has a lot of solar generation, but still the propensity is low. You remember his lifestyle, right? In daytime, where he is? Office. So if he's in office, he generates power, and there is no way to store it. It's wasted, right? Either if there is a provision to provide a feedback, then it's okay, but otherwise it's wasted. So that's why the propensity is 0.2. But now, if I sell it with battery, because he's not present in the daytime, but what if he can store that energy and discharge in the night time? So that's why the propensity for buying solar for battery is higher than solar, so it's 0.55. But still, there's an issue here. If he invests in solar and battery, it costs some amount of money, right? So is he going to get back that much? No, because his consumption is not that much, because he is office goer. So what if I just sell him batteries? Why I'm selling him battery? Because his rate plan says it's high from 5 to 9 p.m. and he consumes a lot during that time. So what if he charge his battery in the off-peak hour and discharge in the night time? He will save a lot of money, and investment is less than this. So from my perspective or engine perspective, this is the most viable thing which we should be selling to Bob, and that's why the propensity coming as 0.8. So you can see how intelligent the system is if you are providing a lot of information. Similarly, for EV, it's not like I just look in the neighborhood and say Bob should buy an EV, because he has an EV. So that's why the propensity is 0.1. It's not 0, because he might replace his EV. It's not new Tesla model he wants to purchase. So it's okay, but still, this is not the first customer which I should target for selling EVs. So you can see how intelligent this engine becomes if we are able to derive the information like we see in different profiles. So again, we have all the information to fill his propensity profile, and that's it. Similar ways, we can fill his engagement profile, neighborhood profile, and whatever profile we can create out of it. And now this is the complete profile of Bob. You can stamp it and say, I know a lot about Bob. You are my customer. I can sell a lot of things to you. Okay. This is scary, right? Professor Reitman just talked about some of the things like what is AI, right? So I'll show you one simple example. It's not really complicated. It's the simplest one I could come up with. There are deep layer networks as well, where I can keep repeating this image again and again and again and say, you provide input in this side and you get output here. But you'll not understand what is happening in between. So I'll just make you understand what with a single layer neural net. So all the use cases till now which I have given to you was based on just one input derived at a time. So as I said, if I know he is having a single speed pool pump, I can sell variable speed pool pump. This is just one-to-one mapping. Now think of a scenario when I have all the informations. Now I can combine all different informations together. And then how many use cases I can create out of it. This is the neural net architecture. So this is our profile engine, which creates a lot of input. This is our processing layer, which combines different input. And then this is the output layer, which creates a lot of use cases for you. Either it could be e-saving maximization, DSM, or you can say propensity to buy, or monetization. So you can come up with n number of use cases here. And this is the most interesting part. We just touch based on this. And I don't have time to go through the processing layer because it's a bit complicated. But I can tell you, like, if you have a lot of inputs, you can create a lot of outputs as well. And those outputs are very much meaningful for a user. So this is one example which I'll take because I don't know how much time I have. So for different users, we have these profiles created just now. Like I know appliance profile, I know consumption profile, I know lifestyle profile, I know home profile. So in general, what we tend to do, suppose we want to target users for a DSM program. So you want to shift load, or you want to pick up a user to say, okay, you have inefficient appliances, you buy my appliance. Or this is the efficient one, you just replace it with this one. How to do it, how to pick a list of users. So currently what happens in the market is people just tend to segment the users. But I tell you, segmentation is not personalized. Segmentation is based on some attributes, say consumption. So you just say, okay, mid-consumption, high consumption, low consumption. All the mid-consumption users are useless for targeting or saying, how to save energy, because they don't have that much energy to save. Just start targeting the high-end users. But it's not necessary always. It's just you don't have much information. That's why this is a crude way of doing it. What if you know, like, this is high consumption user, the energy consumption is happening because of this appliance, and this appliance is running from this time to this time. Then you know more about that user. And if you have a demand, or if you have a target saying from 12 p.m. to 6 p.m., I want to decrease my load, what to do? This decision can be taken based on just the total power consumption. This can be done only if you know TOU of each appliance, because pool pump can be shifted easily. But if somebody say, uses flow water heater, you can't say, start taking bath in the night time and stop doing it in the daytime, right? So it makes more sense to have all this information and get the list of users which can be targeted. And also you get to know the distribution of the user at a particular geography. So you can plan your visits accordingly, like the efficient way. You would not like to go in this area, say we just have 3 users here. Why? You should visit this area. You should visit this area where you can target like tons of users. So this is the platform which we have created called DSM platform. So it will provide you a list of users and also the distribution of users which should be targeted for a particular program. So these are the inputs which utility have to provide. These are the information which you have already derived for a user. And at the end, you are going to get the list of users who are the most effective users for your program. So this is the complete solution which we are building right now. So from utility to Bidgely, we have user data lake, which consists of smart meter data, demographic data, call center data if you want to work on your churn reduction kind of thing, or interaction data and all those data. It goes to our profile building engine, which I just showed you like with 4 examples. It creates a lot of different profile for a user: energy profile, lifestyle profile, engagement profile, propensity profile, appliance profile. Once you have all this information, you can again feed it to our next AI layer, which is application utility AI layer. And then you get to do all your use cases. So these are the use cases which we can fulfill for utilities. So from Bidgely to utility, we can send enhanced itemization to users, which will enable him to understand more about how and why this energy consumption pattern is present in his house. Then we can send personalized recommendations, as we have seen during the course, like how we can send it. We can do DSM, we can do energy efficiency, we can do monetization, and then you can come up with your own use cases as well. Like, you want to do something, we'll try to see if through this information we can do it? And if yes, we are good to go. So with this, I'd like to conclude my presentation.